This video we're going to talk about quadratic equations and how to solve them. We're going to use several different methods. We're going to solve by factoring or taking the square roots. Then eventually we're going to get into the quadratic formula. So first of all, remember the quadratic equations are any equation of degree 2. And we usually have it where we have it in some form of ax squared plus bx plus c, where again a, b, and c are constants. And the highest exponent is that 2, or the whole equation is of degree 2. So solving by factoring, we use this when the trinomial, or the quadratic, because we can have difference of two squares, is factorable. And the first thing to remember is we have to set it equal to 0. That is the biggest thing we have to remember, that if we're going to solve by factoring, we are doing with the idea that we're trying to find binomial factors that we can set equal to 0. So going back on the stuff from before, when we factor this out, we're going to take this into two binomials, have it set equal to 0, and we know that this is going to be x minus 6 and x plus 4. If you don't remember how to factor, you can go back to a previous video and check it out. But the idea is that if I have this whole binomial is equal to 0, then it's equal to 0. Then this whole equation is equal to 0, and the same thing with this. So basically what we do is we take each binomial factor. We can set this is equal to 0, whoops, or we can set the other factor equal to 0. So solving this, x minus 6, adding 6 to both sides, this is equal to 6. Subtracting 4 from both sides, this is equal to a negative 4. So that's kind of the steps we go through, but what on earth does this mean? Well, let's look at the idea of if x was equal to 6. So if x was equal to 6, then we're simply going to put that in there and say x is equal to 6 minus 6 times 6 plus 4. So 6 minus 6 is 0, and 6 plus 4 is 10, so 0 plus 10 is equal to 0. That checks out. Well, what if I did the other one? What if I used the other binomial? So what if I had that same equation, x minus 6 and x plus 4, but instead I'm going to use this one. So I have negative 4 minus 6 and negative 4 plus 4. Is that really equal to 0? So, and we have negative 4, negative 6 is negative 10. Negative 4 plus 4 is 0, so this is equal to 0. So negative 10 times 0 is 0. And that also checks out. So if either of the binomials is equal to 0, then it makes the entire side, or the entire quadratic, equal to 0. So doing this again, we're simply going to factor it, and I'm doing this factoring very quickly, so if you don't remember how, this is going to be x minus 5 both times. So we set this factor equal to 0, and, well, we could set the other one. They're exactly the same, so it's going to be x equals 5 no matter how you do it. If you have two identical binomial, in other words, a perfect square, you don't have to write it out twice. I'm just demonstrating that this is how it works. Now this one is not set equal to 0, so we can't just start factoring the 1 until we subtract the 10 from both sides. And what I actually have is 2x squared plus x minus 10 is equal to 0. And then I got to factor that. And that is that trinomial factored. So then we set each factor equal to 0. And we can have two answers. Like here, there was only one answer of 5, but here we had x equals to 6 and x equal to negative 4. So solving this one's a little less intuitive because I've got that coefficient of 2. So I'm going to subtract 5 from both sides. So I've got 2x is equal to negative 5, or x is equal to a negative 2.5 when I divide both sides by 2. In this binomial, I've got x minus 2 is equal to 0. So adding 2 to both sides, I get x is equal to 2. So again, I have two possible roots. Factoring this one. This is 5x minus 1. This is 5x minus 1. Same binomial, so I only need to set one of them equal to 0. But just be careful we don't assume by glancing at it solved, because I think this answer might be 5. But in fact, if I notice, I'm going to do that answer over there. I've got 5x is equal to 1, or dividing both sides by 5, I get x is equal to 1/5, not 5. So make sure you take care of that each time. Now these are more complicated, but it's the same idea. We're going to distribute through the parentheses and then combine like terms and set the whole thing equal to 0. So go ahead and pause your video and do that. So here's one equation where we distributed the x through, but we can't do any work until we get 0 on one side. So what I did is I pulled everything. I pulled this negative x and negative 12, or excuse me, x plus 12, subtracted both xa and 12 for both sides, and then went over here to factor it. This trinomial factors down to this, and then setting each piece equal to 0, we get that. So doing the same thing, I've got x squared plus x minus 1, and then I've got to distribute this. This is going to be 2x squared, 1, and that's plus 5x plus 2. And then let's subtract all of these things to go over this way. So we have 0 is equal to x squared plus 4x minus 3. Excuse me, plus 3. So then let's factor this. And this factors into x plus 3 and x plus 1. Whenever you have this, then you need to set every binomial equal to 0. So 0 is equal to x plus 3, and 0 is equal to x plus 1. So x is equal to negative 3 here, and x is equal to negative 1 there. Another way we can do it is by taking the square roots and completing the square. So when we have this equal, we know that if y squared is equal to 16, we know that y is going to be equal to 4. But keep in mind, when we have this, recognize that not only can y be 4, but y can also be negative 4. Because if I put this in, 4 times 4 is 16, but also negative 4 times negative 4 is 16. So my answer to problems set this way is the negative and positive version. Keep in mind, when I'm asking it this way, this is only asking for the positive roots, so we just say 4. We never say the square root of 16 is negative 4. So if it's set up this way with y squared, we give the negative and positive answer. If I just have that radical over it, it's only the positive answer. So doing this one, the first thing we have to make sure we do is isolate the x squared, or the variable squared. So I'm going to divide both sides by 4. So I've got x squared is equal to 18 over, oops, not 18, 81 over 4. And then what we do is we take the square root of both sides. So the square root of x squared is simply x. And then when we take the square root of a fraction, we can take the square root of the top over the square root of the bottom. And again, keep in mind that the answer is always the negative and positive of that answer. This one we can actually solve two ways. I can say this is the difference of two squares, so I've got, not x. I can say this is y minus 10 times y plus 10, doing the good old factoring, is set equal to 0. So setting this one equal to 0, I get y is equal to 10. Setting this binomial equal to 0, I get y is equal to negative 10. But if I decided to do it by taking the square root, so I can take and move this 100 over, so I have y squared is equal to 100. Taking the square root of both sides, this is y, and the square root of 100 is 10, but we have to acknowledge that it's a positive and negative version of both, which is exactly what we just got here. Oops, let me scroll. So we got negative 10, positive 10. We got negative 10, positive 10. Same thing both sides. Okay. Let's do it again. First of all, we're going to divide both sides by 5, get that squared value by itself. So I have z minus 2 squared is equal to, this is supposed to be the positive, 80 divided by 15, which is 16. So then taking the square root of both, the square root of this side is z minus 12, and the square root of 16 is a positive negative 4. So when we want to get z by itself, we have to add the 12 to both sides. But now I've got this weird thing going on. I've got z is equal to positive negative 4 plus 12. And we know the solution to a lot of quadratics is two answers. So remember that this is saying positive 4 plus 12, which we know is 16. And this is also saying negative 4 plus 12, which is 8. So that's how we get the two answers, the negative positive, but it's not necessarily just the square root. This one we had to work it in. We had to take the plus 12 at the end. So we take the square root of both sides, and we know that this is z minus 2 is equal to a positive negative 4. Well, how do we deal with this? If I'm going to isolate z, I've got to add 2 to both sides. But how do I do the positive negative 4? So what we do is this means that z is equal to positive negative 4 plus 2. So what we do is we say, well, that's two parts. That's positive 4 plus 2, and then I have negative 4 plus 2. So positive 4 plus 2 is 6. Negative 4 plus 2 is a negative 2, and that's how we get our two answers. So solving the rest of these, we can do the same. I can move this 75 over to the other side. So I can have y plus 4 squared is equal to 75. And then take the square root of both sides. So this is now y plus 4, and this is the positive negative root of 75. So we have to subtract 4 from both sides, and we have y is equal to the square root, positive negative square root of 75 minus 4. Now if you remember, we can go back to simplifying it. The square root of 75 is simply 5 square root of 3. That's simplifying. And this we have minus 4. So that means the answers are two parts. Positive 5 square root of 3 minus 4 and negative 5 square root of 3 minus 4. You can get actual numeric approximations by like taking the square root of 3, and then you can do you can find the actual numerical approximation, but this is what we call the exact answer when we're looking for it. Solving by completing the squares turns any trinomial into a perfect square trinomial. And so what we're trying to do, we're trying to add the c term, or the square of b divided by 2. So this is the way I always complete it. I will take half of the middle term, which is 8. We're talking about the coefficient. And then I square it to get the back term. Take half of this term, which is negative 3, and then I square it to get the back term. Take the half of this, which is 1.5, and then I square it to get 2.25. Take half of the middle term and square it to get 20.25. So each time that's what we have. And to build the binomial, what that means is this is the item that goes in the binomial twice. So once I've completed the square into 64, this is the same as x plus 8 multiplied by x plus 8. This is the same, because this was a negative 3, as x minus 3 times x minus 3. This is the same as x plus 1.5 multiplied by x plus 1.5. And if you're not sure, go ahead and pause the video and distribute one of these. X minus 4.5, I forgot to put the negative here. It is exactly the same sign as what's there. So this was negative here, negative, negative, positive, positive on the right. But this is x minus 4.5 both times. And then we always clean it up, since that's the same as x plus 8 squared. This is the same as x plus 1.5 squared, so on and so forth. So completing the square, this is what we do. We will complete the square on the one side and then add the term on the other side. So if I'm looking at this, minus 4x, and I'm going to spread it out just a little, minus 23 over this side. So to complete the square, we take half of it and we square it. So I'm going to change the color here just for a second. On the next one, we take half of it. I'm going to spread that out. And I'm actually going to take that extra constant over to the other side. So then we take half of it and we square it. Again, we're going to take the, oops, do that in purple. So we're going to spread this out. I'm going to spread this out x squared plus 6x. I'm going to move that negative 7 over to the other side, so this is 7. And then I'm going to take half and square it. Oh, take half was 3, and then square it, which is 9. Doing the same thing again. We've got x squared plus 3x, and I've got the 2 already over here, and I'm going to take half and square it. Oops, we're going to add that purple. I'm going to make it purple, and I'll show you why. Because what we've done basically is I've added something that completes the square. Here's the problem. It's 2.25 in there actually. Is I've changed the value of the equation because I added something to one side, but I didn't add to the other. Whatever you add to this quadratic to make it a perfect square, you have to add to the other side of the equation to balance it. Whatever you added to this side, we have to add it to this side to balance it. We added a 9 to this side, I've got to add a 9 to this side to balance it. And adding 2.25, I got to add 2.25 to balance it. So then we know that this now becomes the middle term of our, or this becomes the back of our binomial. So our new binomials, x minus 2 times itself, are just squared, and negative 23 plus 4 is a negative 19. This is now inside my binomial, so it's now x plus 3 times x plus 3, or squared, is equal to 14. This is now x plus 3 squared is equal to 16. This is now x, because again, we're taking this number, that half number is what builds our binomial. X plus 1.5 squared is 4.25. Adding all those numbers together. And then we solve it like we did before. I'm going back to the beginning. I'm going to do this in a different color. Here, let's do it in green. But once we have this, then we take the square root of both sides. X minus 2 squared square root is x minus 2 is equal to the square root of negative 19, plus or minus. So we add 2. So I've got x is equal to square root of the square root of negative 19, or plus or minus the square root of negative 19 plus 2. Or we take that negative 1 out, we say plus or minus I square root of 19 plus 2. Doing this one, we take the square root of both sides, so I've got x plus 3, and then I've got the square root of 14, but remember it's a positive negative square root of 14. So we subtract the 3 from both sides, so I've got x is equal to positive negative square root of 14 minus 3. Let's do it again, taking the square root of both sides, so I've got x plus 3, and this is equal to the square root of 16, or positive negative 4. So then I'm going to add 3, subtract 3 from both sides. So x is equal to positive negative 4 minus 3. So you have positive 4 minus 3, which is 1, or you have negative 4 minus 3, which is negative 7. And this is the idea of completing the square. Most people will migrate to using the quadratic formula, so we are going to move on to that. There are other ways to do it when a is not 1, but we are going to skip on to the quadratic formula. And this is the one that everybody seems to like, is that we have x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And this is the thing to keep in mind, that everything is in the form ax squared plus bx plus c. So before we evaluate anything, it also has to be set equal to 0. So these first 4 problems we see here are set up perfectly. So what I want you to do is take a minute and figure out what is A, B, and C in this. I'll show you in the first one. A is always the coefficient of the variable squared. B is always the coefficient of x. And C is always the constant. So pause the video and do it for each one. So that should be what we have here first. Now when we look at this, we're simply going to place the values in to the same quadratic formula. And I do expect you to memorize this because we're going to use this over and over and over again. So the first thing it says is negative b. Well, b is here. It's already negative. So x is equal to a negative b. Well, negative 2 is a positive 2. Plus or minus the square root of negative b minus 4ac all over 2a. So let's evaluate this. Keep going. So we got x is equal to 2 plus or minus, I forgot to put the squared in there, b squared, so this is negative 2 times negative 2 is 4, minus a negative 12 all over 2. So this is 2 plus or minus the square root of 16 all over 2, or 2 plus or minus 4 over 2. So our final answer is going to be either 2 plus 4, so 6 over 2, which is 3, or 2 minus 4, which is negative 2 over 2, which is a negative 1. So we're just crunching all these numbers out over and over and over again. Doing it again, we have b is a negative 25. I forgot to put that in there. But so a negative b is going to be positive 25 plus or minus the square root of b squared minus 4 times a times c all over 2a. So 25 plus or minus the square root of 625 minus 0, 25 times 5 is 0, all over 2 times a. So we have 25 plus or minus square root of 625 is 25 over 10. So we evaluate this again. 25 plus 25 is 50 over 10. Then we have 25 minus 25 is 0 over 10, which is 0. So go ahead and plop these other values in and see if you don't get the same answer as me. So here are the other answers for these problems. I want to focus on this one because I didn't quite finish it. So I put in the values for A, B, and C and solved it down. But if you'll notice, I'm at this point. You're always going to look and see, 1, can you simplify the radical, and 2, can you simplify the fraction? So I can definitely simplify the radical. Remember, the square root of 12 can be broken down into the square root of 4 square root of 3. So that means this is 2 radical 3. So what I have actually here is 2 plus or minus the square root of, plus or minus the square root of 2 radical 3, which is what we just did here, all over 2. And as we said before, anytime I have a fraction where I can divide every single term by the same number, like this one, so I can divide this one by 2, this one by 2, and this one by 2, so that's exactly what I'm going to do. So what I have now is 1 plus or minus the square root of 1 square root of 3 all over 1, or just 1 plus or minus the square root of 3. And this is what we call an exact answer. If we wanted to see what these values were on a graph, we would find the square root of 3 and either add 1 or add 1 to it or take it away from 1. But this is what's called the exact value. So you're always going to look to see if you can't simplify the radical and also if you can't simplify the fraction, reduce the fraction. So on the next page, pause the video and see if you can't find the answer to these using the quadratic formula. So here are just the answers. If you need to see some of the work, you can contact me for help. Keep in mind that all of your answers have to have 2 values. This one basically had 2 values that were exactly the same. So then we're looking for the ones with complex answers. And we're going to do this exactly the same. So when we look at this one, A is going to be 1, B is going to be 0, there is no coefficient of x, and then C is going to be 64. So go ahead and plug in to the quadratic formula the A, the negative B, and so on and so forth. Now you also might have seen that you can solve this by completing the square or by taking the square of both sides if we move the 64 over. But let's say we did the quadratic. And what you're going to have is x is equal to 0 plus or minus the square root of 64. Square root of negative 64, excuse me, all over 2. Sorry, negative 256 all over 2. When you simplify that radical, this is going to be positive negative square root of 16, or positive, not square root of 16, but positive negative 16 over 2. But don't forget the I, because we had a negative under the square root. So when we reduce this, then we're going to have x is equal to positive negative 16 divided by 2, which is 8i. So we're still doing everything that we did before. We just need to make sure that at the end, when we simplify the radical, we actually pull out the I. So go ahead and solve these, and I'll show you that component. So putting up the answer to this problem, we get positive negative square root of positive negative 7i. In this one, we have 6 plus or minus the square root of 16. Well, again, 16, we can take the square root of 16, which is 4, and the square root of negative 1, which is I, simplifying that. And when we have any single one of these, we can do it by dividing every single term. So dividing 6 by 2, dividing 4i by 2, and dividing 2 by 2. So we didn't even have to put that over that radical. Or that over that 1, excuse me. So go ahead and solve the last one. And that's the answer for that one. Remember, we have to distribute this entire thing out. We can't pull A, B, and C until we've gotten this to be x squared plus 2x plus 1 plus 9 is equal to 7. Then I have to take the 7 off to this side and combine it with like terms. So we have x squared plus 2x plus 3 is equal to 0. Once you combine these two together and take the 7 with it. So then doing your quadratic, A is going to be 1, B is going to be 2, C is going to be 3. And then you'll set it up and you'll end up with the answer there.